So up to now, we have studied about the Zubair triad and Newland's law of octave. तो चलिए आगे बढ़ते हैं and we are going to now see that Mendeleev's periodic table. But before going to Mendeleev's periodic table, let's have the quick revision of the two concepts, that is the Zubair triad and Newland's law of octave, which we have studied in the previous part. So, in the Doberan triad, we have seen that the Doberan tried to make the group of the elements of the three, and he used the atomic mass as the property for the classification of the elements in the periodic table. So he have calculated that the atomic masses sum mean of the extreme two elements is equals to the atomic mass of the middle element, and he could not able to classify the all the elements known at the time of the 1817, as we have seen that at the time of the 1800 only 30 elements were known. So the drawback of the Dobereiner was that he could not able to classify all the elements. So next we have seen that the Newland has came and he proposed the law of octave. As he said that the every eighth element had the similar properties to those of the first. But we have seen that the Newlands also could not able to classify all the elements in his periodic table, and we have seen that the drawback were that two elements were placed at the one box only. Then the cobalt and the nickel, which are the metals showing the similar properties with the iron, are placed under the halogens, that is the fluorine, chlorine, bromine. So this is also one of the drawback. And we have also seen that he could not able to classify all the elements, as he able to calculate all the classify elements up to the calcium only, as we have seen here that he has made the 7 by 8, that is the 56 boxes, and uh, classified the elements according to their atomic masses as the property he used. And also this fails that he could also not be able to classify all the elements. So later मेंडेलीव्स पीरियोडिक टेबल या बाद में मेंडेलीव आए, तो चलिए देखते हैं कि क्या हुआ, मेंडेलीव ने क्या किया. The Russian scientist Dmitry Mendeleev developed the periodic table of elements during the period of 1869 to 1872 AD. Mendeleev's periodic table is the most important step in the classification of the element. So, as Mendeleev had brought a revolutionary step in the classification of the periodic table. So, Mendeleev considered the fundamental property of the elements, namely the atomic mass, as the standard and arranged 63 elements known at that time in an increasing order of their atomic masses. तो मेंडेलीव ने क्या सोचा कि चलो क्यों ना जो भी 63 एलिमेंट्स उस टाइम नोन थे, तो उन्होंने सोचा कि एटॉमिक मास एज द फंडामेंटल प्रॉपर्टी यूज करके सारे एलिमेंट्स को उनके इंक्रीजिंग एटॉमिक मासेस के हिसाब से अरेंज कर देते. Then we transform these into the periodic table of the elements in according to the with their physical properties and chemical properties of these elements. तो उन्होंने जो एलिमेंट्स थे उनकी फिजिकल एंड केमिकल प्रॉपर्टीज के बेसिस पे उनके एटॉमिक मासेस को ध्यान में रखते हुए उनको इंक्रीजिंग ऑर्डर में अरेंज कर दिया. And he classified all the 63 elements known at that time. Mendeleev organized the periodic table on the basis of the chemical and the physical properties of the elements. These were the molecular formula of the hydrides and the oxides of the elements, melting point, boiling point, and densities of the elements and their hydrides and oxides. So the chemical and the physical properties which Mendeleev considered for the classification of the elements were the molecular formula of the hydrides and the oxides of that element, then their melting points, then their boiling points, and then their densities of the elements, then the hydrides and the oxides of that particular element. These all the properties of the physical and chemical properties of that elements Mendeleev considered and classified the elements in the periodic table. Mendeleev found that elements with the similar and the physical chemical properties repeat after the definite interval. और मेंडेलीव ने ये यहाँ पर देखा कि जो भी एलिमेंट्स थे तो वो एट द पर्टिकुलर इंटरवल उनकी जो केमिकल और द फिजिकल प्रॉपर्टीज थी वो सेम बिहेव कर रही थी. ऑन द बेसिस ऑफ दिस फाइंडिंग मेंडेलीव stated the following periodic law, or on the basis of that ऑब्जर्वेशन, तो मेंडेलीव ने यहाँ पर एक लॉ प्रपोज किया जिसे हम पीरियोडिक लॉ कहते हैं। दैट वाज प्रॉपर्टीज ऑफ द एलिमेंट्स आर पीरियोडिक फंक्शन ऑफ देयर एटॉमिक masses। ये हमें ध्यान में रखना है, as this is the important one, as with respect to the exam also, that properties of the elements where the atomic masses of their are the periodic function of their atomic masses. As we have seen that atomic masses has considered as the fundamental property by Mendeleev and all the Dubereiner, Newland, उन्होंने सबने जो atomic mass को लेकर as a fundamental property उन्होंने classification elements का किया है। So मेंडेलीव ने जब देखा कि at the particular interval एक जो फर्स्ट एलिमेंट है तो उसकी प्रॉपर्टीज जो है वो रिपीट हो रही है, एंड ही देन proposed that properties of the elements are the periodic function of their atomic masses. The vertical columns in the Mendeleev's periodic table are called groups। जो वर्टिकल कॉलम थे यानी तो उनको उन्होंने नाम दिया ग्रुप, एंड while the horizontal rows are called as a period, और जो हॉरिजॉन्टल रोज थे, हॉरिजॉन्टल कॉलम्स थे, तो उनको उन्होंने पीरियड्स नाम दिया। So as we can see here that R2O, these are all the hydrates and the oxides formula and the physical properties and the chemical properties which Mendeleev considered for the classification of all the elements. So 63 elements were known at that time. So here we can see that hydrogen atomic mass 1, lithium 7, sodium, natrium that is 23. So he found that every at the periodic interval, lithium shows the similarity with the hydrogen, sodium shows the similarity with the lithium, potassium shows the similarity with the sodium, and all on the basis of considering all these hydrates and oxides formulas, their melting point, boiling point, and all. So he classified the elements and arranged them properly in the periodic table, and also proposed the law of the periodic law that properties of the elements are the periodic function of their atomic masses. सो यहाँ पर अगर हम ठीक से ऑब्जर्व करें तो यहाँ पर कुछ ब्लैंक स्पेसेस भी है जो कि यहाँ पर मेंडेलीव ने लेफ्ट कर दी थी, उनके बारे में भी हम आगे देखते हैं। द जनरल मॉलिक्यूलर फॉर्मूला ऑफ द कंपाउंड्स shown as R2O, R2O3, etc. in the upper part of the Mendeleev's periodic table are written as R2O, R2O3, etc. in the present system. Introduction to the scientist. Dmitry Mendeleev was a professor in the St. Petersburg University. He made separate cards for every known element showing its atomic mass. He arranged the cards in accordance with their atomic masses and properties of the elements, which resulted in the invention of the periodic table of the elements. और जैसा कि हमने देखा कि according to all the consideration of the atomic masses as the fundamental property, so Mendeleev able to classify all the elements which were known at that time period. That was, as we have seen, that he proposed the element of the periodic table at in the era of 1869 to 1872, and he able to classify all the 63 elements in the periodic table. So, as we have seen about this, we are having the question that think about it. तो चलिए देखते हैं वो क्या पूछते हैं हम हमें हमें क्या सोचने के लिए कहा जा रहा है। देर आर द सम वैकेंट प्लेसेस इन द मेंडेलिस पीरियोडिक टेबल। जैसा कि मैंने आपको बोला कि यहाँ पर कुछ वैकेंट स्पेसेस है जो कि मेंडेलीव ने लेफ्ट ओवर कर दी थी। So, in some of these places, the atomic masses are seen to be predicted. Enlist three of these predicted atomic masses along with the group and the period. तो उन्होंने क्या किया था कि जो यहाँ पर जो वैकेंट स्पेसेस है तो इनके जो एटॉमिक मासेस है वो उन्होंने प्रिडिक्ट भी किए थे कि यानी जब फ्यूचर में जो एलिमेंट डिस्कवर्ड होगा तो उसको हम इस बॉक्स में प्लेस कर सकते हैं। Second, due to uncertainty in the names of some elements, a question mark is indicated before the symbol in the Mendeleev's periodic table. What are such symbols? तो चलिए देखते हैं merits and demerits of the Mendeleev's periodic table. So as we can see here, the merits of the Mendeleev's periodic table. Science is the progressive. There is a freedom in the science to revise the old inference by using more advanced means and methods of doing experiment. These characteristics of the science are clearly seen in the Mendeleev's periodic table. So, which while applying the law that properties of the elements are periodic function of their atomic masses to all the known elements, Mendeleev arranged the elements with a thought that information available till then was not final, but it could change. As a result of this, Mendeleev's periodic table demonstrates the following merits. तो क्या थे मेरिट? First, atomic masses of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. For example, the previously determined atomic mass of the beryllium, that was 14.09, was changed to the correct value, that is 9.4, and beryllium was placed before the boron. तो सबसे पहला जो मेरिट था एटॉमिक पीरियोडिक टेबल का जो मेंडेलीव ने प्रपोज किया था, तो उसमें उन्होंने देखा कि सम एलिमेंट्स जो थे, कुछ जो एलिमेंट थे, तो वो प्रॉपरली एटॉमिक मासेस के हिसाब से अरेंज नहीं थे। जैसा कि हम देख सकते हैं कि बेरिलियम का जो एटॉमिक मास जो कैलकुलेट किया था 14.09 was changed and corrected to the 9.4। तो बेरिलियम जो कि जिसका कि एटॉमिक मास बोरॉन से कम निकला, तो बोरॉन के पहले मतलब बोरॉन के पहले बेरिलियम को प्लेस किया गया। जैसा कि हम यहाँ पर देख सकते हैं कि बोरॉन का 11 है और बेरिलियम का जब कैलकुलेट किया गया तो 9.4 आया। तो बोरॉन आसानी से सिंपल बात है कि as we have seen that atomic mass has considered as a fundamental property for the classification of elements by the Mendeleev also. So he found that the atomic masses, he arranged the elements according to the increasing atomic masses. So boron, beryllium found that atomic mass is 9.4 and boron was 11. So obviously that beryllium will be placed before the boron. Second, Mendeleev kept vacant places in the periodic table for elements not discovered till then. Three of these unknown elements were given the names as Eka-boron, Eka-aluminium, and Eka-silicon from the known neighbors, and their atomic masses were indicated as 44, 68, and 72 respectively. Not only this, but their properties were also predicted. Later on, these elements were discovered and named as the scandium, gallium, and germanium respectively. The properties of these elements matched well with those predicted by the Mendeleev. See table 2.4. Due to this success, all were convinced that the importance of the Mendeleev's periodic table and this method of classification of elements was accepted immediately. तो सेकंड जो मेरिट था मेंडेलियस पीरियोडिक टेबल का, तो उन्होंने जैसा कि हमने डिस्कस किया कि सम वैकेंट प्लेसेस यहाँ पर उन्होंने छोड़ दी थी। तो ये वैकेंट प्लेसेस क्यों छोड़ दी थी? सो he has proposed the on the basis that of the atomic masses that these the elements which will be discovered in the future will be placed at these places. So he has also predicted the names for that. That was the Eka boron, Eka aluminium, and Eka silicon, and also he has predicted the atomic masses of them also, that's 44, 68, and 72 respectively, of the Eka boron, Eka aluminium, and Eka silicon. But later when these elements were found and they have found the similar properties of those, as we have seen, he has formed the groups and the periods in the periodic table, groups and periods. So later when these elements, that is the scandium, Sc gallium Ga, and germanium Ge was found, so they have found the similar properties with that particular group and the row. So that elements get occupied the place of the Eka boron, Eka aluminum, and Eka silicon respectively. मतलब इका जो बोरॉन था वो था स्कैंडियम, इका जो एल्यूमिनियम था वो था गैलियम, एंड इका सिलिकॉन जो था तो वो जर्मेनियम। The properties of these elements matched well with the predicted by Mendeleev and able to take the place at the vacant places in the Mendeleev's periodic table. So atomic masses were predicted, density, melting point, formula of the chloride, formula of oxide, and nature of the oxide. That is the amphoteric oxide. तो चलिए देखते हैं थर्ड मेरिट क्या है। देयर वाज नो प्लेस रिजर्व फॉर द नोबल गैसेस इन द Mendeleev's original periodic table. However, when noble gases such as the helium, neon, and argon were discovered towards the end of the 19th century, Mendeleev created the zero group without disturbing the original periodic table in which the noble gases were fitted very well. तो जैसा कि हम यहाँ पर देख सकते हैं कि मेंडेलीव के पीरियोडिक टेबल में जो उन्होंने प्रपोज किया था उसमें नोबल गैसेस के लिए कोई जगह ही नहीं थी। सो जब नोबल गैसेस जब मिले एट द एंड ऑफ द 19th सेंचुरी, सो मेंडेलीव ने क्या किया, उन्होंने एक और ग्रुप बना दिया जिसे उन्होंने जीरो ग्रुप कहा, और सारे नोबल गैसेस है जो भी डिस्कवर्ड हुए थे एट द एंड ऑफ द 19th सेंचुरी गेट प्लेस्ड एट दैट पर्टिकुलर जीरो ग्रुप। यूज यूर ब्रेन पावर में क्या पूछा है हम देखते हैं। Fluorine has the two isotopes, that is Cl35 and Cl37. Their atomic masses are 35 and 37 respectively. Their chemical properties are same. Where should these be placed in the Mendeleev's periodic table, in different places or in the same places? तो यहाँ पर एक इंटरेस्टिंग क्वेश्चन हमसे पूछा गया है कि क्या पूछा है कि क्लोरीन के जो दो आइसोटोप्स है, एज वी हैव स्टडीड दैट आइसोटोप्स, isobars, isotones in the previous standard. So isotopes are those elements having the same atomic masses but different same atomic number but different atomic mass number. That's as we have studied that atomic number of chlorine nowadays we have known according to the modern periodic table that Cl having the atomic number as the 17. But here we are talking about the isotopes of the chlorine, that is the 35 and 37. So as we have seen that all, that is the Dobereiner, Newland and Mendeleev, all three have considered the atomic mass as the fundamental property for the classification of the element. सो यहाँ पर एक क्वेश्चन आ गया कि यदि एक एलिमेंट का अगर आइसोटोप होंगे, जैसे कि यहाँ पर बोला गया है आइसोटोप्स ऑफ द क्लोरीन दैट इज द 35 एंड 37, तो एटॉमिक मासेस 35 एंड 37 है, तो डिफरेंट एटॉमिक मासेस है, तो क्या वो मेंडलीव पीरियोडिक टेबल में कैसे प्लेस्ड हो जाएंगे? Will they occupy the different place in the periodic table or will they have the same place in the periodic table? This was one of the challenge in front of the Mendeleev. So demerits of the Mendeleev periodic table, क्या क्या demerits निकले? Merits, as we have seen that it has placed a very revolutionary role in the formation and classification of the elements and formation of the new, that is the periodic law that stated, we have seen properties of the elements are the periodic function of their atomic masses. These all have brought a revolutionary step in the classification of the elements. तो कुछ demerits भी निकले, तो क्या थे? First, the whole number of the atomic mass of the element cobalt and nickel is the same. Therefore, there was an ambiguity regarding their sequence in the Mendeleev's periodic table. तो atomic masses जब calculate किए गए cobalt and nickel के, तो approximately same थे. So उनको मतलब एक बॉक्स में प्लेस करना या डिफरेंट इसमें प्लेस करना, that there was the ambiguity regarding that in the Mendeleev's periodic table. Second, isotopes were discovered long of time after Mendeleev put forth the periodic table. As isotopes have the same chemical properties but different atomic masses, a challenge was posed in placing them in the Mendeleev's periodic table. So as I have, we have given the question in the use your brain power that there was a challenge in placing of the isotopes in the Mendeleev's periodic table. That was also one of the demerit of the Mendeleev's periodic table. When elements are arranged in an increasing order of the atomic masses, the rise in the atomic mass does not appear to be uniform. It was not possible, therefore, to predict how many elements could be discovered between two heavy elements. So, as the elements were placed according to the atomic masses, according to the Mendeleev proposed classification of the elements. So, when the elements are arranged in an increasing order of their atomic masses, a rise in the atomic mass does not appear to be uniform. मतलब जो एटॉमिक मास कैलकुलेट किया गया था तो वो यूनिफॉर्म नहीं था, मतलब कभी बढ़ रहा था कभी घट रहा था. इट वाज नॉट पॉसिबल देयरफॉर टू प्रिडिक्ट दैट हाउ मेनी एलिमेंट्स कुड बी डिस्कवर्ड बिटवीन टू हेवी एलिमेंट्स. मतलब दो एलिमेंट्स के बीच में फ्यूचर में कितने एलिमेंट्स बीच में डिस्कवर्ड होंगे तो उसके लिए जगह ही नहीं थी. दैट वाज आल्सो वन ऑफ द एम्बिग्यूटी इन द वन ऑफ द डिमेरिट ऑफ द मेंडलीव्स पीरियोडिक टेबल. So later we are going to see one of the demerit, that position of the hydrogen. Hydrogen shows a similarity with the halogens, that is the group 7. For example, the molecular formula of the hydrogen is H2, while the molecular formula of the fluorine, chlorine, that is the F2 and Cl2 respectively. In the same way, there is an similarity in the chemical properties of the hydrogen and alkali metals, that is the group 1. मतलब यहाँ पर जो पोजीशन ऑफ हाइड्रोजन थी तो उसके अंदर भी यहाँ पर एम्बिग्यूटी आ गई कि हाइड्रोजन मतलब जो सिमिलरिटी शो कर रहा था हेलोजन के साथ भी, दैट वाज द ग्रुप 7 एलिमेंट्स, एज वी हैव सीन दैट हियर ग्रुप 7, that the elements are placed fluorine, chlorine, bromine, as we can see, and hydrogen was placed in this group. So hydrogen was also showing the similarity with that of the fluorine and the chlorine, that was the halogens. In same way, there is a similarity in the chemical properties of the hydrogen at alkali metals. Alkali metals, that lithium, sodium, and potassium. So hydrogen was also showing the similarity with that also, and with halogen also. So there was a challenge in front of the Mendeleev, that where to place this element, that is the hydrogen. On considering the above properties, it cannot be decided whether the correct position of the hydrogen is in the group of the alkali metals, that is the group 1, or the group of the halogens, that is the group 7. So there was also one of the challenge according to this, as here we have given two tables, that compounds of the hydrogen, HCl, H2O, H2S, compounds of sodium, NaCl, Na2O, Na2S, similarity in the hydrogen and alkali metal, and similarity in the hydrogen and the halogen, that is the H2Cl2, NaH, NaCl, CH4, CCl4. So with the metals also and non-metals, the hydrogen is showing the similarity of in the chemical behavior, that is the alkali metals, and also with the halogens. So there was also the ambiguity regarding the hydrogen placing. So these are all the four demerits of the Mendeleev's periodic table we have seen here. So ये थे merits and the demerits of the Mendeleev's periodic table, and these are too much extremely important that we should know this, because many of the times it gets asked in the exams also. So we should have to remember about this also. Use your brain power. Write the molecular formula of the oxides, Mendeleev's periodic table. Write molecular formula of the compounds of the following elements with hydrogen by referring to the Mendeleev's periodic table. So this is the task for you. So try to solve this, and if any doubt, then comment in the comment box. मॉडर्न पीरियोडिक लॉ, तो मेंदेलिव का तो यहाँ पर हो गया। मेंदेलिव ने जो यूज किया, तो एज अ एटॉमिक मास एज द फंडामेंटल प्रॉपर्टी एंड प्रपोज द मॉडर्न पीरियोडिक लॉ। सो उसके कुछ डीमेरिट्स भी निकले। सो लेटर मॉडर्न पीरियोडिक लॉ हैज केम इनटू द एग्जिस्टेंस। The scientific world did not know anything about the interior of the atom when Mendeleev put forth the periodic law. जब मेंडेलीव ने जो पीरियोडिक लॉ जो प्रपोज किया, दैट द प्रॉपर्टीज ऑफ द एलिमेंट्स आर द पीरियोडिक फंक्शन ऑफ देयर एटॉमिक मासेस, तो इसके तब लोगों को मतलब उस टाइम ज्यादा इंटीरियर ऑफ द एटम, मतलब एटम के जो इनसाइड जो है, जैसा कि हम आज जानते हैं बिकॉज ऑफ दिस ऑल प्रपोज, दैट एटम के बीच में क्या है, जो इलेक्ट्रॉन, प्रोटॉन, न्यूट्रॉन जो है, तो वो उस टाइम पता नहीं था। So, after the discovery of the electron, scientists started exploring the relation between the electron number of an atom and the atomic number. तो इलेक्ट्रॉन जब डिस्कवर्ड हुआ, तो इलेक्ट्रॉन नंबर और एटॉमिक नंबर में क्या रिलेशन है, इसके बारे में साइंटिस्ट सोचने लगे। The atomic number in the Mendeleev's periodic table only indicated the serial number of the element. In 1913 AD, the English scientist Henry Moseley demonstrated with the help of the experiment done using the X-ray tube that atomic number of an element corresponds to the positive charge on the nucleus or the number of the protons in the nucleus of the atom of that element. This revealed that atomic number is more fundamental property of the element than its atomic mass. तो जब हेनरी मुसले ने 1913 एडी में जब एक्सरे ट्यूब के साथ एक एक्सपेरिमेंट परफॉर्म किया, तो उन्होंने डिस्कवर्ड किया कि एटॉमिक नंबर ऑफ एन एलिमेंट वो है कि जो जितने नंबर ऑफ प्रोटॉन्स, यानी जो पॉजिटिव चार्ज न्यूक्लियस पे जो प्रेजेंट है एलिमेंट का, तो वो जितना है उतना उसका एटॉमिक नंबर है। एंड दिस हैज ब्रॉट वन रिवॉल्यूशन इन द क्लासिफिकेशन ऑफ द एलिमेंट्स, दैट before all were trying to classify the elements according with the fundamental property as the atomic mass, but later जब हेनरी मोसले ने एटॉमिक नंबर एज द फंडामेंटल प्रॉपर्टी, जो कि बहुत मोर फंडामेंटल है एज कंपेयर्ड विद द एटॉमिक मास, सो then then one proposed the solution and found the modern periodic law. तो मॉडर्न पीरियोडिक लॉ क्या स्टेट कर रहा है यहाँ पर, कि properties of the elements are the periodic function of the atomic numbers. So, properties of the elements are the periodic function of their atomic numbers. So, this was the modern periodic law has proposed here. जब एटॉमिक नंबर एज द मोर फंडामेंटल प्रॉपर्टी ये लोगों को जब पता चल गया, जब साइंटिस्ट को पता चला, तो उन्होंने एटॉमिक नंबर के हिसाब से क्लासिफाई करने की कोशिश की। और उन्होंने जो मॉडर्न पीरियोडिक लॉ है वो स्टेट प्रपोज किया दैट प्रॉपर्टीज ऑफ द एलिमेंट्स आर पीरियोडिक फंक्शन ऑफ देयर एटॉमिक नंबर्स। यहाँ पर एक कंफ्यूजन है, मतलब कंफ्यूजिंग है कि जो ये ध्यान में रखने जैसी बात है यहाँ पर कि जो मेंडेलीव ने जो पीरियोडिक लॉ जो प्रपोज किया था, तो मेंडेलीव का जो पीरियोडिक लॉ था वो प्रॉपर्टीज ऑफ द एलिमेंट्स आर पीरियोडिक फंक्शन ऑफ देयर एटॉमिक मासेस। और जो मॉडर्न पीरियोडिक लॉ है वो है कि प्रॉपर्टीज ऑफ द एलिमेंट्स आर द पीरियोडिक फंक्शन ऑफ देयर एटॉमिक नंबर्स। सो वी हैव टू कीप इन माइंड अबाउट द डिफरेंस बिटवीन दिस टू। सो आगे जो है मॉडर्न पीरियोडिक टेबल एंड लॉन्ग फॉर्म ऑफ द पीरियोडिक टेबल दैट वी विल सी in the next part. So if you have any question and doubts regarding this, so we are having the 5 minutes as I am live. So you can put it in the comment box also regarding that. So if you are liking this all part and the content, so do like, share and subscribe, and also suggest these videos if you are having the friends and all who want to learn the science one of the class 10. So now we will stop here and we'll continue with the modern periodic table, that is the long form of the periodic table. As we have seen that properties of the elements are the periodic function of their atomic number. तो atomic number को लेके elements का classification आगे कैसे किया गया, that we will see in the next part upcoming. And modern periodic table जो कि आज हम use करते हैं for the classification of the elements and all, studying the elements behavior and all, that we will see in the next part.